Hey everybody, it's Ripley. I am back again. We're going to talk about hypothesis testing with two samples now. Now, think about what we did in the last chapter. What we had is we had a population, okay? And what we did is we guessed something about that population. So we had a null and an alternative hypothesis, and we either guessed something about the mean or about the population proportion, right? And we said that the mean equaled something, or that the mean didn't equal something, or that it was less than or equal to something, or something of that nature, okay? And then what we did is we pulled a sample out of that. So we pulled a sample out of that and we found an X bar, and we either knew the standard deviation of the population or we had to use the standard deviation of the sample. Remember, that was the difference between being able to use a Z-test and being forced to use an S-test. If we were testing around P, remember, they had to be independent. It was more of a binomial situation. The requirements were in P and NQ were both greater than or equal to 5, et cetera, right? And then we did our test. We had a test of some sort, and then we either used confidence intervals, we used critical values, and we used p-values to determine whether or not, remember, wait, I've got a little ahead of myself. Remember, we always established an alpha. We also had an N, right? There was always an N here. And then we used all sorts of techniques to figure out whether or not it was feasible to reject the null hypothesis. Okay? Now, when we're testing two samples, what we're saying is, let me give you an example, okay? The easiest way to explain this is, I believe that the proportion of women that support a specific candidate is greater than the proportion of men that support a different candidate. Okay, so here's the way this works. Let me show you. We've got women over here. We have a population of women, and we have the population of men. Like before, like with confidence intervals and hypothesis testing, we're going to start with proportions. Okay? Now, we've got all women, all voting women, and all voting men. And then we do exactly the same thing. We grab a sample of them, and we bring that sample out. We grab a sample of men, and we bring that sample out. Okay? And then we're going to figure out a p-hat for these guys, which we're going to call p-hat 1, and we're going to figure out a p-hat 2 for these guys, and we're going to have n's and p-hats and all sorts of stuff that we're going to deal with. And then we compare these two. And we decide whether or not there is truly a difference. Now, think about what, let me cut this off a little bit. Think about what the null and the alternative hypothesis for this would look like. Because really, if you think about it, if I know what the null and the alternative hypothesis look like, and I've chosen my alpha value, then all that I need is a test value. All right? And I'm not going to insult your intelligence by going through a whole bunch of these. What I'm going to do is I'm going to give you the test value. I'm going to give you an example straight out of the book, because by now, in other words, I'm going to give you what the test is. In other words, you know, whether it's a Z, a T, whatever. I'm going to give you, I'll write up what the assumptions are. Well, and then I'm going to give you guys an opportunity to try it on your own, and then I'll do it out for you, okay? So think about this. The null and the alternative hypothesis, just like before, the null hypothesis is, that the proportion of women is equal to the proportion of men. It always contains the equality, always, okay? And then this can either be P1 is not equal to P2, P1 is greater than P2, P1 is less than P2, etc. Just like we did before, okay? Now, there's a difference with this. We don't traditionally do this with proportions, but I do want to set up. Let me say, I believe, I'm going to make a claim. I believe, that the difference in support of, wow, that's terrible handwriting. I'm sorry, you guys. Of candidate A of women You guys, the construction's going crazy today, so bear with any weird noises, okay? Candidate, what's going on here? A of women over men is 5%. In other words, it's 5% higher in women than it is in men. I suppose I could have written that a little bit better. Now, the difference between when we're doing this with just one sample versus two samples, you have to realize that what we're doing here is we're talking about two samples. The difference between when we're talking about one sample and two samples is that we can actually talk about differences. So I could actually write the null hypothesis up for this as P1 minus P2, the true proportion of women. 5% is gonna, let's make that 8%, because otherwise we might get a little confused with alpha. Let's say that it's 8%. Okay, that P1 minus P2 equals 0.08. All right, versus the alternative hypothesis, which is P1 minus P2 is not equal to 0.08, is greater than 0.08, is less than 0.08, etc., etc., etc. Now this is pretty cool because it allows us to do this little funky business right here, which is really nice. In other words, we don't just have to say that they are equal to each other, because really, if you think about it, let me change colored pens right here. This is exactly the same as saying P1 minus P2 equals 0. We can be much more specific in what we believe the difference to be, and then we can test that difference. All right? Now remember, this only works when we're talking about two samples, not just one sample, because then we pull a sample out and we say, okay, the mean or the proportion or something equals a value. But now we're talking about the differences between those two samples. All right? Okay, cool. Now, before we get crazy, like I said, these are really simple. We're going to blow through these quickly. The only difference, excuse me, between what we're going to do here and what we did in Chapter 8 is the test, the T, the Z, etc., is a little more complicated, but we're not going to panic. All right? The first thing that we need to do is we need to talk about the assumptions. Okay? First things first, the assumptions. So right now we're talking about differences. That looks terrible. Whoa, wow, differences, pardon me, excuse me, in proportion. Let's do this one first, just like we did before. Start with proportion, work our way to means, okay? Assumptions. All right, number one. The number one assumption is that the samples are independent. Samples are independent from each other. Now think about that. What that means is the probability of a certain person favoring a candidate, a woman favoring a candidate is different, is unaffected by the probability that the man favors a certain candidate. Now, think about that in the context of the problem that I just talked about. You couldn't, in other words, you couldn't sample a husband and a wife. Theoretically, there'd have to be a strong argument that said, okay, he does not affect my voting and she does not affect my voting, because those wouldn't be independent, would they? I mean, think about that. If you affect one another's voting, it's like, honey, I think you should vote for candidate C, not candidate A. Well, guess what? You potentially you violate this independence assumption. Okay? And then standard issue, it's a proportion. So from each population, in my case it was the men and the women, all right? From each population, we draw a sample, all right? We'll call it of size n, such that NP1 and NP2 are both greater than or equal to 5. Just like before. All right? Just like before. Nothing to it. Okay, now, the formulas for this are beefy. You're going to have to bear with me for just a second. Okay? Now, again, just kind of plant it in your brain, just to keep it simple. Think of P1 as it's the population proportion for population 1. Population 1. In this case, the women. Okay, P2 equals population proportion for population 2. In other words, those are the parameters. Okay, those are the parameters. Let's see. N1 is sample size, and this is going to get a little boring. Sample size from population 1. Okay, and N2 is the sample size from population 2, et cetera, right? X1 equals the number, remember, this basically comes from binomial, all right, of hits, just like before, from from N. Whoa, sorry about that, my eraser's acting goofy. From N1. In other words, I take a sample size of, of 600. I say, do you favor candidate A? X1 would be the number of women that said, yes, I favor candidate A. Okay, so let's see, X2 equals number of hits from N2. Easy peasy. So I know that P1 hat equals sample proportion for POP1, and P2 hat equals sample proportion for P2, or for population 2 portion. Sorry, you guys, that's terrible. I apologize. Okay, so